Okay, so in your answer to the previous question, you should have compared fission to fusion, and we can compare that in a number of categories that are shown in this chart. For me, this is the best thing to learn when it comes to revision for this part of the topic. This table contains everything really that you need to know. So we can compare them in terms of the fuel. Just notice a little typo there, so if you change that in your notes, it is uranium 235. Okay, 235 is the mass number of the isotope we use. It's quite rare. It's hard to mine out of the ground. There's only a certain amount of it. For fusion, however, we use hydrogen isotopes. They're a lot more abundant, but we tend to use deuterium and tritium. I would learn off those words as well and the spelling. Conditions to start the reaction. To start a nuclear fission reaction, uranium 235 nuclei must absorb a neutron. Let's tick these. That's easy. To get fusion to happen, we need very high temperatures, hundreds of millions of degrees centigrade, very high pressures. That's a drawback. Okay. In terms of the previous one, this fuel is more plentiful than this fuel. The products of a fission reaction then, when we split the nucleus, is daughter nuclei, which are radioactive. Okay, so they emit radiation, which can be dangerous, rather than for fusion, we just get our helium-4, which does not emit radiation, and in both cases we get energy produced as well. However, we get more energy produced per kilogram of fuel for nuclear fusion. Okay, so if we had a kilogram of hydrogen and a kilogram of uranium, we'd get 4 times as much energy from fusion. If we had a kilogram of coal and a kilogram of uranium, we would get 1,000,000 times as much energy out of the uranium. And if we had a kilogram of hydrogen compared to a kilogram of coal, we would get 4,000,000 times as much energy compared to that. So you can see we get a lot more energy out of nuclear reactions than we do chemical reactions. Advantages then of fission is we have these nuclear power plants that provide employment opportunities and skilled employment for lots of people. It doesn't emit carbon dioxide. It is reliable in that it will generate electricity any time of the day, any weather conditions, and we can increase and decrease the amount of electricity produced. Nuclear fusion, well, we can give advantages, disadvantages, but we haven't achieved it yet. We haven't got a nuclear reactor that works at the minute. So it does have the potential to solve the world's energy needs, provided those difficulties can be overcome. The isotopes are nearly inexhaustible. We have so many of them, they're so abundant. And it does, like fission, it doesn't emit greenhouse gases. Disadvantages then of fission. Many people don't want to live near one because of the risks that are involved. It is difficult and expensive to store the waste that is produced. That's the major drawback, really. There is a risk of a leak or a meltdown. There have been major incidents in Ukraine and Japan, but that's only 2 incidences out of all the nuclear power plants all over the world that have been running for 60, 70 years now. Even though the fission power plant doesn't produce CO2, getting the fuel can produce carbon dioxide, so the mining, transport, purification of uranium is difficult. That will emit greenhouse gases into the atmosphere, and the power plants are expensive to decommission at the end of their lives. The main disadvantages of fusion then over here is it's really, really difficult to achieve. Talking about with current research, it might be another 50 years before we actually get a power plant that can use fusion. That might be optimistic. The joke about fusion is it's always 50 years away. My parents were told when they were at school, you'll have nuclear fusion reactors in 50 years. When I was at school, I was told we'd have them in 50 years. That was 20 years ago now, and now I'm telling you we'll have them in 50 years. We may or may not. I wouldn't bet it. When we get them, it'll be a relatively new technology. It will be a difficult thing to achieve, and that will tend to make them expensive to build as well. Okay, you can see this is all recapped. In fact, this summary is taken directly out of your specification. It's worthwhile reading over that and just seeing the wording that they use for particular things, but we have covered most of it in there. What there should be then below this when I post it is below this video there should be a little form or quiz that will test you on both this topic and radiation. Fill that in, and then that is you finished the year 11 side of the course. We will pause to give everybody a little bit of time to get caught up, but once we get into June time, be that in school or at home, we'll be working on the first topic of year 12, which will be waves.